Hi, this is Jacob Fu for COP3330, and here is my submission for assignment 0 in Limprog. So now I'm connected to Limprog 2 on my CS account. I will, in my COP3330 directory, I will open up the file, which is fizzbuzz.cpp. So here is the file. I only have a CPP file since it's a rather simple code project, so I don't need any other files. To output and input, I need the IOStream library, so I included it there. And then everything else is included in my int main function. So we wanted to have 3 numbers with the modular division, so we have 3 integers. And then so I have the C output and the C input for each of the 3 numbers so that the user can input them. And here I have my for loop that goes through all the integers in between 0 and the first number. You see how the second conditional whatever has the less than or equal to, so it includes the first number. So if the first number was 5, then it would go from 0 to 5. Okay, so here's the bulk of the code. Here, if I is divisible by the second number, then it will output fizz. And then if that's not true, then if I is divisible by the third number, then it will output buzz. And if both these 2 if statements are not true, and if I is divisible by the product of the second and third number, then it will output fizzbuzz. Note that if number 2 isn't equal to 0, then it will always output fizz. However, if number 2 is 0, then it will return an error because then you're dividing by 0. Okay. So how like the standard fizzbuzz works is that they're not inclusive if statements, but else if, so that only one of these is true. So that for this to be true, it just must be the first one true. For this one to be true, this one to be true, this one has to be true, and this one has to be false. And for this one to be true, then these 2 must be false, because the compiler goes from top to bottom. So it starts here, then here, then here. And that's basically the bulk of the code. I have a output new line statement for formatting, and then the return 0 for the main function. And that's the end of the code. Save there, and then compile. So compile that, and run it. So here, enter the first number. I'll enter 5, enter. Second number, 4, enter. Third, 3, enter. And so what just happened is that it started at 0, which is always divisible. So it outputs fizz, and then it goes to 1, which is indivisible by 4, was not divisible by 4, not divisible by 3, and not divisible by 12. So it skips. Then goes to 2, which is not divisible by 4, not divisible by 3, and not divisible by 12. So it skips that. And then it goes to 3, which is not divisible by 4, but is divisible by 3. So then it outputs buzz, since it's divisible by the third number. And then it goes to 4, which is divisible by the second number, which is also 4, so it outputs fizz. And then 5 is not divisible by 4, 3, or 12. So then there's the end. To output fizzbuzz, you need this to be true and these 2 to not be true. So let me try that. I'll use 7, 1, 7, 2, and 7. Oh, never mind. 14, yeah, okay. 14, 3, wait. I need like a 5, 10, no, 6. Oh yeah, You see, the code will work. I'm just, yeah, I can't find the modular arithmetic for it to work. But it's like 426. Yeah, because it's difficult to find like a for numbers that will equal fizzbuzz without it already equaling fizz. Yeah. Hmm. But you understand the logic. Yeah, I can't find an example. But you'll understand the logic. You, because you have fizz or they like, it can't be divisible by two or three, so that's a hard requirement. But um, there's my submission for assignment 0. All right, thank you for your time.